Now there is a direct relation between power and speed. When you have an electric motor, you apply a constant force to move the object at a constant speed. The power output of the motor can be shown to be product of the force and speed. When the force is constant, the work done can be found by the equation work equal the force by delta D. And we know P equal W over delta T. Instead of W, we use F delta D over delta T. That would give you power equals force by delta D over delta T. We know delta D over delta T is V. So the expression for delta D over delta T means specifically the average speed, V average. So P equals the force by the average velocity. So that's the relation between power and speed. Example on that, we have a car with a mass of 2,000 kilograms traveling uphill at a constant speed 90 kilometers per hour or 25 meters per second. The force of air resistance, which is opposite to the motion, is 450 Newton, pulling the car backward while the car is pushing forward. The slope for the hill is 6 degrees, the theta over here. Draw free body diagram to show external forces acting on the car as it moves uphill. We know that we have F gravitation and we have F air pulling against the motion, and we have the velocity in this direction. We have the normal force upwards for the surface of the object. That's one. Then determine the forward force needed to maintain the car's speed. So over here we have the car is not accelerating, so we have the net force. If you remember from previous chapter, the net force here is 0 because we are moving the car in a constant speed. So we have parallel and perpendicular forces to the inclined hill. So the forward force would be F forward equal to the sum magnitude of the force of air resistance, and we can do that by abbreviations and equations. F net parallel equal the F forward plus the FG parallel plus the F air. F net parallel would be F forward plus FG parallel plus F air without directions. FG parallel would equal, as you know from the previous analysis, theta will be here, so that's minus F sine theta, which is minus mg sine theta. We have the m, we have the g, that would give you FG parallel minus 2.851 by 10 to the power 3. And the F forward would be, after rearranging this equation, 2.5 by 10 to the power 3 newtons. And if you want to calculate the power output of the engine using forward force and the speed at which the car move along the ramp, we have P equals the F forward by the V average. We have the F forward as 2.5 by 10 to the power 3. We have V average as 25 meters per second. P in this case would be 62.5 kilowatts.